Alright, so in this video we go over section 7.6 equations involving radical expressions. So these equations are, like the title says, they're gonna have radicals in them. Okay, so let's see how are we going to go about these ones. Well, in this box right here, you have essential steps to follow and solve this equation. So what you want to make sure first is isolate a radical term on one side of the equation. In other words, make sure, well, because we're going to have two equations with two radicals, so you want to isolate one. If that's the case, well, for the first ones, we're going to have only one radical expression. And then apply the power rule by raising each side of the equation to the power equal to the index of the isolated radical. And that's how we are going to essentially, solve the equation, get rid of the radical symbol. And then after doing that, we're going to remain with an equation that contains no radicals, or it may contain a radical. Okay, and then in the end, we need to check our answers. All right. So let's do one example. For letter A, notice the radical term is actually isolated. So what you want to do is, in this case, you want to undo the radical or get rid of the radical by raising to the, well, in this case the index is 2. We need to square both sides. You know how these two cancel, and we are going to be left with 3x minus 2 equals to 5 squared, which is 25. And then notice the equation that is left has no radicals anymore, and just solve this baby equation, which is a linear equation. That's 3x equals 27, and then divide both sides by 3. All right, divide by 3, and x equals to 27 over 3, which is 9. But we're not done yet. We need to check our answers in this case. So let's check. So to check, what you want to do in this case is, well, go back to the original equation, the one that has the radical. Square root of 3 times minus 2 equals to 5. And in this case, quantity in parentheses, which is going to be 5. I mean, not 5, actually 9. And that's 3 times 9, which is 27 minus 2. 5 equals to 5. 27 minus 2 inside, that's the square root of 25. And in this case, the square root of 25 is 5, and 5 equals 5. Therefore, this is an okay solution. Okay, let's go about letter B. So letter B, well, this one, notice the radical is not isolated properly. So what you want to do in this case is divide by 3. All right, it's divide by 3 because we can, in order to get the radical by itself, 5x plus 3. And that equals to negative 2/3. All right. And then the next step would be the following: to square both sides and then solve. All right. So when we square both sides, notice how these two cancel the index, and leaving us with 5x plus 3 equals to negative 4 over 9. So there's a few ways to solve this equation. Well, I'm going to multiply both sides by 9, so we're not left with any fractions. It's easier to work with integers only. 9 times 5, that's 45. 9 times 3, 45x, and 9 times 3, that's 27. And boom, just cancel, negative 4. So what you want to do now is subtract 27. And subtract 27 to, let's see, subtract 27. So that's going to be 31 and 45x. And then divide both sides by 45. and x equals to 30, actually negative 31 over 45. And then, of course, this is potentially a solution, because what do we want to do here? Well, check the solution. So let's check. So check in the original. So 3 times the square root of 5 times, what is this going to be? Well, that's actually negative, right? Oh no, never mind, it's not negative. I think I made a mistake here, because when we square this number, that's supposed to be positive. Well, so never mind, let's fix this. So 27 minus 4, that's a 23. 23, and it's positive, so 23 over 23. Okay, let me erase this properly. 23 over 45, 23 over 45, and 23 over 45. And yes, that's going to give us a wacky number. I agree, but yeah, we will have to deal with this, of course. Plus 3, and that's is that equal to negative 2? Well, we'll find out. So 5 over 40 over 45, that's going to give us a 9 in the denominator. 3 times the square root of 23 over 9 plus 3 equals to negative 2. And well, if we look at this, well, let's 23 nines plus 3, 23 over 9 plus 3, math, frac, 50 over 9, all right? So that's 3 times the square root of 50 over 9. And well, in this case, equals to negative 2. And then, well, the root of 9 is going to go outside as a 3 in the denominator. 3 root of 5, of 50 actually, over 3 equals to negative 2. Boom, boom, cancel. And then in this case, we're essentially saying that the square root of 50 is equals to negative 2, which in this case, this is not going to be a legitimate solution. And what we say in this case is no solution. All right, no solution for this equation. All right, let's look at another example, in this case one with cube root. How are we going to work with an equation like that? Well, in a very similar way, we want to isolate the radical. So what you want to do in this case first is subtract 5 to both sides. All right, subtract 5. Cube root of 3x plus 1 equals 3 minus 5, which is negative 2. Now, in this case, what you want to do is not square both sides, but actually you want to cancel the cube root by cubing both sides. All right, cancel, cancel. Actually, 3x plus 1 equals to negative 2 cubed, that's a negative 8. Okay, be careful with the odd powers. And then subtract 1 to both sides. That's going to give us a negative 9. 3x equals negative 9. Divide both sides by 3. Boom, x equals to negative 3. Well, let's find out if that is a legitimate solution. So let's check. So the cube root of 3 times plus 1 plus 5 equals to 3. The number that we want to check is negative 3. That's 3 times negative 3, which is negative 9, plus 1 plus 5 outside of the radical. This 5 is outside, be careful. And negative 9 plus 1, that's a negative 8 inside of the cube root, plus 5 equals to 3. And then the cube root of negative 8, well, the cube root of 8 is 2, but because there's a negative, keep in mind that for odd indices, we can find radicals with negative. We can evaluate negative roots of negative numbers rather, but the negative number goes outside. Plus 5 equals to 3. Negative 2 plus 5, that's going to give us a 3 equals to 3. So in this case, we have a legitimate solution. So solution, solution, no solution. This one came out weird. All right, let's see what we have. What we have next? Well, we have one that has an x plus root up to x minus 3. Well, let's see. So number one, again, you want to isolate the radical term. So subtract x to both sides, leaving us with square root up to x minus 3 equals 3 minus x. All right. Well, in this case, need to be very, very careful. Well, because I'm going to square, but in this case, I'm going to square the binomial. And to square this binomial, well, so cancel the radical with power, and 2x minus 3 equals, well, the formula for the binomial square, if you want to recall that, a minus b quantity squared equals a squared minus 2ab plus b squared. Alright, so you might to just apply that one. 9 minus 3x times 2, that's a 6x, and then plus x squared. Okay. Well, in this case, as opposed to the previous examples, well, what do we have here? We have a quadratic equation that hopefully works to be solvable by factoring. Otherwise, well, maybe other methods. 2x, subtract the 2x on both sides, add the 3. So cancel, cancel, and I'm gonna have everything on the other side of the equation. I'm gonna have, well, let me have a 0 here, that's fine. 9 plus 3, that's a 12. Negative 6 minus 2, that's a negative 8. X plus x squared. Well, that's not the standard way to solve a polynomial equation. We might want to have everything on the left hand side and write it in descending order of powers. Okay, set that equal to 0, and hopefully this is factorable by the double bubble method. So factors of 12 that add up to negative 8. Well, 4 times 3, not likely. Well, because 4 plus 3, that's a 7, not an 8. Well, 6 times 2, oh, that one works. Negative 6, negative 2, minus 6, minus 2. Right? Negative times a negative is positive. Negative plus another negative, it's even more negative. That means here x minus 6 equals to 0, and x minus 2 equals to 0. Which in the end, x equals to 6, x equals to 2. Two potential solutions. Let's find out which one is possible. So when you have an equation like this, there's a few possible scenarios. Number one, both of them could be the solutions. Another scenario is one is a solution, the other one is not, or maybe the third scenario, none of them are solutions to this. So let's check. Let's check x equals to 6. So I'm going to go back to the original equation in which, well, let me write the equation. X plus root up to x minus 3 equals to 3. So x, which is in this case 6, plus the square root of 2 times minus 3. Okay, so that's 6 also. 2 times 6 is a 12, minus 3, and don't forget to add this 6 right here. 6 plus the square root of 12 minus 3, which is 9, equals to 3. And then let's see, the square root of 9 is 3. And 6 plus 3 equals to 12. Well, in this case, 12 is not equals to 3. So in this case, 6 cannot be a solution. So x equals 6 is an extraneous solution. We call this extraneous solutions when it's a potential solution that comes out of the algebra, but it actually doesn't check with the original equation. So let's see. Let's now check x equals to 2. So in this case, okay, I'm going to write the equation x plus square root of 2x minus 3 equals to 3. So what we're going to do is 6 plus the square root of 2 times 6 minus 3. Is that equal to 3? We'll find out. Okay, let's plug it in, simplify. So that's, oh, not 6, it's actually 2. Okay, 2. So 2 plus the square root of 2 times 2, which is 4 minus 3, equals to 3. 2 plus the square root of 1 equals to 3, and the square root of 1, what's that? Well, that's a 1. And 2 plus 1 equals 3, which equals to 3. And in this case works, in this case doesn't work. So x equals to 2 is a solution. So this one is fine, the other one is not. So that's why it's important to check all your solutions to your equations, because otherwise, if you just put both of them on MyMATLAB, you may get it wrong. Alright? Now let's look at the last example of this section, example E, which in this case is an equation involving two radicals. How are we going to go about this one? Well, as the method explained at the beginning, on the previous page rather, isolate one of the radicals, right? So isolate the radicals, and in this case what I'm going to do is to isolate the one that is already a positive by adding square root of 3x plus 4 to both sides. So in this case, goodbye, and 2x minus 4 under the radical equals square root of 3x plus 4 minus 2. All right. Yes, this one is going to be a little bit more involved. It's going to be a little bit heavier on the algebra. So bear with me on this one. Square both sides. Okay, for the first one, it's really nice and cool. Okay, cancel these two to leave us with 2x minus 4. And in this case, well, we have one term minus another term square. You might want to use again the binomial square formula that we learned in chapter 5 when we multiply binomials. In particular, this one is one of those special products. So this is going to be square of the first term plus 2 times the product of the first and the actually minus, because there's a minus, the square root 3x plus 4 times 2, and then plus the second term square, right? That's a squared minus 2ab plus b squared. And let's keep simplifying this one. Well, so in this case, cancel radical with power, and 2 squared equals 4. 2 times 2 is 4. Well, we'll see. 2x minus 4, that's going to be left with 3x plus 4, minus 2 times 2, which is 4 square root of 3x plus 4 plus 4. Okay. Now let's see, what about the rest of this? Well, let's okay, so let's combine like terms in this case. 4 plus 4, that's going to give us 3x plus 8 minus 4 square root of 3x plus 4. And 4 minus 2x. So I mean 2x minus 4. So now, well, again, so you might want to repeat the process if you go back to your previous page. So if you are left with a radical, isolate that radical. And in order to do that, let's minus 3x minus 8, minus 3x minus 8, and cancel, cancel. That's gonna leave us with negative 4 square root of 3x plus 4. And 2x minus 3x, that's going to give us negative x. Negative 4 minus 8, that's going to give us negative 12. Alright, what are we going to be left for this one? Let's see. So notice we have a bunch of negatives. And number one, you might want to factor out the negative. X plus 12 equals to negative 4 square root of 3x plus 4. And in this case, if we divide by negative 1, divide by negative 1 to get rid of that negative sign. And 4 square root of 3x plus 4. All right. So what are we going to do in this case? Well, I mean, you want to isolate the radical. That's what you want to do. But the thing is, to isolate the radical, we would need to divide both sides by 4. But the left-hand side would leave us with denominator. So I'm not going to square. I'm not going to divide by 4 for that reason. Instead, I'm going to simply square both sides. All right. And so that's going to be, well, using the square binomial formula, x squared plus 24x plus 144. Yes, x times 12, that's 12x times 2 is 24x, and square of the other two terms. And then in this case, this square is going to affect both the 4 and the radical. Number 1, 4 squared equals to 16. And in this case, square cancels the radical, leaving us with 3x plus 4 only. And in this case, well, let's distribute. Let's distribute this one. So x squared plus 24 x plus 144 equals to 16 times 3. Okay, let me use the calculator. That's 48. And 16 times 4, that's 64. And now from here, what you want to do is have all terms to the left-hand side. That's what I'm going to do now. Subtract 48x, subtract 48x, and subtract 64, subtract 64. Okay, 24 minus 48, that's going to give us x squared minus 24x, and 144 minus 64, that's going to give us 80. All right. So let's see what about this one. So now I'm going to look for factors of 80 that add up to negative 24. All right. Are there any? Well, actually both negatives, because the sum has to be negative and the product has to be positive. So let's play with the numbers. Well, I'm going to divide 80 by, I don't know, I'm going to divide 80. Let me divide 80 by 20, see if that works. Well, yes, 20 times 4, right? Because 20 plus 4 is 24. But if we do both negatives, negative 20, negative 4, that should do it. And in this case, our potential solutions, x equals to 20 and x equals to 4, all right? So let's see. Again, keep in mind that we have to check. We have to check. So what I'm going to do here is check x equals to 20. So the square root of 2 times 20 minus 4 minus square root of 3 times 20 plus 4, is that equal to negative 2? Okay, let's find out if that is true. So 20 and 20. Okay, so 20 times 2, that's 40 minus 4 minus, let's see, 40 minus 4, and then 30 times 2, that's 60 plus 4 equals negative 2. Okay, so 40 minus 4 reduces to 36, which is a perfect squared, and then 60 plus 4, that's 64, which is a perfect squared. And in this case, well, that's 36. The square root of 36 is 6 minus the square root of 64, which is 8. And 6 minus 8 is negative 2. And indeed, x equals 20 in this case is a legitimate solution to the equation. All right, so in this case, checks. Now let's check x equals to 4. So the square root of 2 times 4 minus 4 minus the square root of 3 times 4 plus 4. Is that equal to negative 2? Well, let's find out. So that's 2 times 4, 3 times 4. So 2 times 4, which is 8, minus 4 under the radical. And 3 times 4, which is 12, plus 4. Is that equal to negative 2? Well, let's find out. So 8 minus 4, that's 4. Minus 12 plus 4, that's a 16. Both are perfect squares. So the square root of 4, which is 2, minus the square root of 16, which is 4. And in this case, 2 minus 4 is negative 2, which equals to actually negative 2. And in this case, again, this also checks. So in this case, they are both solutions. X equals 4 and 20. All right, and this is a good place to quit. I'll see you in the next video.